Welcome to this new video where we will solve the alphabet board path problem. We have this board of letters and we are given a target string, and we want to know the required moves to make target by using the board. We have 5 possible moves: U to go up, D to go down, L to go left, R to go right, and exclamation mark to write the letter of our actual position in the board. Note that the board doesn't change, we always start from the top left cell and we cannot go out of the board. For example, if the target is Leet, we start from the top left cell, then we go down, down, right, we go up, then up, right, 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 we write, then down, 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 we write, and we finished. As output, we get D, D, R, exclamation mark, U, U, R, 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 exclamation mark, D, 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 exclamation mark. The idea to solve this problem is to have two variables I and j that represent our actual position in the board. They start at 0, 0 because we start from the top left cell. Then for each letter, we go to it and write it while saving the moves. First of all, we need a table where we map each alphabetical letter to its position in the board. We can write it manually because the table is static, it doesn't change, but we can do it with code, because there is a relation between the position of a letter in the alphabet and its position in the board. If a letter is at the position I in the alphabet if we start counting from 0, then it will be in the row I divided by 5 and the column I modulus 5. 5 because the width of the board is 5. For example, if the letter A is at position 0 in the alphabet, then the letter N is at position 13. Its row is 13 divided by 5, which is 2, and its column is 13 modulus 5, which is 3. Then N is in board of 2, 3. In code, for each position I of the 26 positions in the alphabet, because we have 26 letters, the actual letter is A plus I positions. For example, if I is 13, then we take the char code of A, we add 13, and we convert it to a character again, we get N. And in the map we put I divided by 5, I modulus 5 at that letter. The tuple represents its coordinates. Now that we have the board, we can start traversing it. We put I and j at 0, 0 as explained earlier. Now for each letter in the target, we want to go from cell ij to the cell next I next j, where next I next j are the coordinates of the actual target letter, which we can get from the map we made now. To do so, we need two loops, one to move vertically to go from I to next I, and one to move horizontally to go from j to next j. Moving vertically means that we will either go up or go down. To know which move to do, we compare I and next I. If I is smaller than next I, then I is on top of next I. We need to keep going down. Else if I is greater than next I, then I is under next I. We need to keep going up. So in code, while I didn't reach next I, if I is smaller than next I, we go down, so we add D to our moves and we increment I to go down in the board. Else, we go up, we add U to our moves, and we decrement I to go up in the board. Now to go from j to next j, same logic, but with right and left. If j is smaller than next j, then we need to keep going to the right. Else if j is greater than next j, then we need to keep going to the left. In code, while j didn't reach next j, if j is smaller than next j, we go to the right, we add r to our moves, and we increment j to go to the right in the board. Else, we go to the left, we add L to our moves, and we decrement j to go to the left in the board. Now that I met next I and j met next j, it means that we're at the position of the actual letter, we write it, we add the exclamation mark to our moves. And in the next iteration, the same process will happen for the next letter, and so on until we finish writing the target. After the loop, we just join our moves to return them as a string and not as an array. By the way, if you're wondering why I didn't directly make a string of moves, it's because adding a character to a string in Python creates a new string, which would slow down the process by doing it at each move. Now you may think that we solved the problem, but we have edge cases. In our algorithm, we're moving vertically then horizontally, so to go from N to Z for example, we'd move like this. But this is invalid because at some point we go out of the board, which is not allowed. This case happens when Z is the destination. To fix this, we start by moving horizontally then vertically. By doing so, to go from N to Z, we'd move like this, which is valid. In code, we just swap the two loops. But the problem now is when we start from Z, because to go to N, for example, we'd move like this. Remember that we're moving horizontally then vertically. And you can see that we're going out of the board. To fix this, we don't swap the loops again because we'd get the initial problem. Fortunately, this edge case happens only when we start from Z, so we can add a condition. The idea is that if we're at the letter Z and we want to go to a letter other than Z, we go up by one cell and we continue to work normally, just to avoid going out of the board. For example, if we want to go from Z to N, we go up once, after it we move horizontally then vertically as usual. In code, we add a condition before the loops. If ij represents the coordinates of Z and the actual letter then we want to go to is not Z, we go up once, we add u to our moves and we decrement I. We wouldn't have these edge cases with a full board, but because this board has missing cells, we need to handle edge cases. Now we can say that we solved the problem. For the time complexity, the maximum distance between two letters is 9, so we may need 10 moves for a single letter, 9 to move in the board plus 1 to write the letter. And we have n letters to go to, where n is the length of the target. We get 10n, which gives an O of n time complexity, because 10 is a constant. And for the space complexity, we have at most 10n moves to store, which gives an O of n space complexity. We reached the end of this video. I hope that you understood the solution. Subscribe and like if you enjoyed the video, and see you in the next one.